Okay, listen up. So first things first. I want everybody to listen to this. Oops, didn't work. Hold on. Might be that it doesn't. Hang on. Oh, I know why. No, I don't. Hang on. Where'd it go? There it is. Okay, let's see. Just want to make sure that maybe this is it. Still didn't work.
Happy birthday, Jade.
I was primed, but there you go. Happy birthday. All right, anybody else's birthday? I missed it last time. Anybody else's birthday? Happy birthday to you if it is. Okay. First of all, if we haven't gotten if you haven't gotten the handout, we can get it later. It's not a big deal, but there is one today. Okay. Boy, it feels like I haven't seen you guys in forever, right? It's been like a week and a half. It's been forever. We have a ton of things to do today. I don't think we will get to the last thing on here because the other things will take a while. But I wanted to chat about the midterm. Hopefully you guys saw the Piazza post that showed you how to get your grade on the midterm. If you haven't, take a look. We'll talk about the midterm, talk about homework 3, which we just provided, and then homework 4, which is the new one. And then we're going to talk about these things called copy constructors and assignment overload, which is what I think most of you guys struggled with. Not particularly that, but particularly you tried to do something like this. Try to do something like this in your homework 3. You tried to say something like major waitlist Q, whatever it was, equals temp Q. Right? Did anybody try to do that? Yeah, a whole bunch of people, right? And all of a sudden you're getting memory leaks and you're getting seg faults and all this problem, right? You can't do this unless you've written copy constructor generally and. You can't do this unless you've written the assignment overload, which we will talk about today, and you will all be pros about it. I am not a fan of C++. I've told you guys that before, right? It is not my favorite language. Memory management, this fits under another part of how C++ handles memory. So you got to know it, unfortunately. So we'll talk a lot about that. Okay? Questions before we get going? All right. So here's first thing first. Oh, there's a quick little Unix tip of the day. I'm not going to actually show it to you. Because we're talking about trees, there is a program called tree, which you can run in your directory, and it's just like ls, except it gives you this nice, fun little tree-based output for your program. So you can do that, and you can play around with it. You can actually ignore folders and all the stuff that ls allows you to do, but you can do that with this function called tree. So it's kind of fun. It gives a little tree. The tree is the tree, kind of like the tree we talked about before, where it's like many, many children for each node, right? Like the bin directory can have 2 programs in it, okay, etc. All right, so that's the tree command. Try it out on your own, and it's kind of a different way to look at your files. Okay, here's the deal with the midterm. All right, average was about 87%. That will probably go up a little bit because people's assignments were graded wrong. Like I guarantee you somebody in this room had something that we graded incorrectly based on what you and I would both agree are the correct answers. Okay? I think it was a fair test. It was probably a little bit easy, as it turns out, to have an average that high. But overall, I'm very happy with you guys and your performance on it. Okay? So hopefully you did as well as you'd hoped, I guess. But if you do have questions specific to the midterm, you can ask me. If you do want to regrade, my policy is generally, if you look through your whole test and you say, yeah, in this part, maybe I should have gotten a point off, and this part I did get a point off, and those would even out, I'm going to regrade your whole exam. If you ask me to go fix some error, I'll probably look through the rest of your exam and go, oh yeah, you didn't do this quite right, if it's legitimate. Right? So in other words, it's just going to limit the amount of time I have to talk about minor errors. If it's 1 or 2 points, it's probably not the end of the world, right? And there were 4 bonus questions. Anybody want to go over the bonus questions? Anybody care what they were? What piece of clothing does an ASCII stegosaurus wear? A top hat. Remember when I did the little cow say, but we did the stegosaurus and he had a little top hat? Most of you guys got that right. What branch of the military is Chris in? And yeah, so let's see. What cue-related behavior infuriated? This was the one where I had, if you just said like something about the lunch line or whatever. No, it wasn't about, it was about like the kid cutting in line, right? That was the cue-based behavior I was worried about. Jumping the cue, in that sense. And then what does Google say when you search for recursion? Did you mean to search for recursion? Yeah. Funny Google joke. Okay, that's that. Other things about the test. Okay, so you can see up here, most of the problems were pretty well done by everybody. Pretty high grades for each individual question. I graded the ones that were the programming type ones. Like if you had to do, like the one for the linked list, I graded that one. Some of you guys do need to review linked lists and how to do like removes and inserts and things, because you forgot to do deletes in some cases and forgot some of the basic stuff. I did see a lot of pictures drawn. Great. That was like key, right? I wanted you to, like if you need to figure out what you're doing, draw the picture. A bunch of you guys forgot to like specifically worry about the corner case of the head. That was a big one too. Okay? And then the recursion question. Most of you guys did all right on that. There were a couple times where I explicitly put what you should have done, but if you do the following, if you do something like this, if you say return same tree, whatever, right? And then in the next line you say return same tree something else. What's wrong with that? This one returns from the function. This line never even gets called, no matter what happens in this function, right? If you return with this, whatever this returns, this will never get called. It's just it's a matter of, that's how C++ works. When it sees a return, and unless there's an if statement around it or something, it's going to return, right? So you got to watch out for that. Some people forgot to check the return values of the trees. That was another one. You have to check that. Other people forgot to check the data in the trees. Like you said, oh, if same tree is equal, blah, 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 you got to actually check and see if the data is the same, right? It's not just that it has the same number of nodes or placement of nodes. It's whether the data is the same for it. Okay, so there were some issues with that. But for the most part, I was very impressed with your abilities to write the code. So that was good. Does anybody else have any specific questions that they were confused about so far? I would be happy to answer them either in office hours or on your own. Yeah, David?
Yeah, sure. The one area where I kind of tripped up, I think I see where I went wrong, but I'm guessing it would probably be helpful to go over, was the question about how expanding an array would affect the asymptotic complexity. So my initial intuition, and maybe it's common, like, oh, well, you have to copy everything, so it's linear. And then I was like, oh, wait, but as you go to infinity, that happens less and less. So actually, but I don't know, maybe just going over.
Yeah, no, you're absolutely right. So I mean, what Dave is talking about is this idea of, hey, we always say that the stack operations are order 1, right? And that's why they're awesome. But every so often you have to do this linear-based behavior where you're expanding the tree. So doesn't that change the asymptotic behavior? No. right? That asymptotic behavior is based on what's happening most often, right? Most of the time you're searching, or you're doing what, or you're rather returning the top of the stack or popping or pushing. And in the sense of how often does it happen that you expand? Not often. If I said, oh, you have to expand every time you push, sure, that would be linear. But if we only expand every, especially if we're doing it by powers of 2, right? You expand after like let's say you start with a Q capacity of 10. You expand at 10 and then 100 and then, 10 and then 20 and then 40 and then 80 and then 160, and it just, the amount of time between expands shrinks, shrinks, shrinks. So yeah, so that's the kind of thing I wanted you to think about. I mean, it was a bit of a tricky question, but that's why I asked it. Yeah. That wasn't true. Oh, all right. Oh, now I see how it is. I would not say that was a trick question. It was a tricky question, but it's certainly not a trick question.
So just to clarify,
Yeah.
like
Yeah.
say that you're, I don't know, like not do the normal proven method, and you're like, instead of, I don't know, doubling the size of my array, I'm going to increase it by 10. That would be linear, right? Even though it'd be once every 10 times?
No, it still wouldn't be linear, because it would basically be, well, let's think about this. Every 10th time you're doing it.
Because it's a multiple of 1/10.
Yeah, I guess you're probably right. If you were not smart about expanding, you might be able to argue that it's linear, but that wasn't the point, right? The point was, is the asymptotic behavior affected by this like very infrequent operation? No, that's the idea there. Yeah, good question though. Yeah, good question. Anything else off the top of your head? Yeah.
Related, not really related to this question specifically.
Mm-hmm.
There were a couple of other things on practice stuff.
Yeah.
Like when we're talking about asymptotic behavior, just asymptotic behavior, there's worst case, best case, and then there's an average case.
Right.
What exactly do we call an average?
Right. I tried to be very explicit about what I meant when I asked the question on the midterm. But the average case is, let's say you had random nodes and you're inserting them into a tree. Like what's the behavior going to be for that tree versus like a specific example of a degenerate tree that goes all the way down in one direction, right? So in the sense of average, I don't mean explicitly like the average. I mean like in an average case, what happens? Like that's kind of what I was getting at, not the worst or best case. In other words, yeah. And for most of the things we're talking about, we stay at a very low level on that. Yeah, good question. Yeah.
How do you see the breakdown of basically your graded test?
It's on the website. What do you mean? In terms of?
Not the score, but physically what we got points off.
If you click the grade.
Oh, yeah. Sorry. Click the grade and it'll give you the PDF of your test. Yeah. Sorry if you guys didn't realize that. Yeah, it's a link. I guess I didn't make that explicit. Yeah, so just click the link and I'll give you the PDF and it'll tell you everything you got wrong. Right. Okay. Other questions? Okay. So if you do have other questions or concerns about grading, I guarantee you some people got some questions. We took points off we shouldn't have. Then let me know. Okay. Homework 3 that we just provided. So lots fewer memory leaks. Does that make sense? Lots fewer? Probably not. My poor grammar aside, you had fewer memory leaks this time. 10% of the class memory leaks instead of like 75. So very good. For what it's worth, it was a little easier to avoid them on this assignment, but good job. You guys, some of you are still relying on Provide too much to do the tests for you. I don't know who saw if you guys saw the Piazza post about somebody saying, hey, the test 13 failed or passed on Provide, but failed on my test when I did it on my own computer. And then we figured out that we were testing that test incorrectly. Like we thought it was a different test. So I fixed it, and then all of a sudden lots of people's test 13 failed, right? Why would you get to that point where you're like, oh, that test fails, but I'm going to try Provide anyway? You know what I mean? Like that was the main that we gave you from the beginning. You need to test that yourself too. Like you got to test the ones we give you, and you should be writing your own tests. All right? I think that's I can't overstate that. We had a big discussion in the earlier class today about what's a better way of doing this. I could just stop giving you any tests, and in fact, a couple assignments from now, you won't get any tests. You'll have to do them on your own. But I could also, just like Comp 11, just tell you what we tested, but not tell you the exact test, so you have to go write your own. That's not a terrible idea. I could also limit the number of times you can provide, right? I could, I think, rightly give you 2 provide chances, right? The first one, you see what your errors are, and it gives you all the code that caused the errors, and you copy that code and test it, and then you provide the second time, and you know exactly what's going to happen. Like that should be the way it works, right? Like that should be the way, because you see all the tests that failed. That's another idea. I won't do that, but I may at some point limit it. I think people are getting like, the people who are submitting like 30 times, you're probably doing too much submitting. You're probably relying on provide more than you should be in that sense. Okay? Like I said, setting queues equal to each other, that caused a lot of headaches. That's why we're going to spend today talking about how to avoid the problem with that. You can do it legitimately, but you just have to know how. Okay? All right, other questions on homework 3, the one we just finished? No questions? OK. All right. I thought it was good. I think you guys have done good. We're going to start grading it tonight. I just haven't gotten all the details about the grading done, but we're going to start grading it tonight. You should see the results pretty soon. All right, homework 4, the one that's out now. This is a pretty straightforward assignment. Like, in other words, all you have to do for this assignment is properly implement a binary search tree. OK, we've talked about all the functions. We've talked about how to do, what's the hard one for a binary search tree? Remove, right? There's 3 cases. You have to handle each case. You have to handle the case where the root's null. You have to handle, I mean, let's put it this way. Right now I'm up to 21 tests, and I'll probably have up to 40 tests on this one, because there's lots of stuff to test for. Lots of little places go wrong in this. So it's a straightforward assignment, but lots of little corner cases you have to deal with. So that's what's going to be the tricky part about this, getting your own tests to work right. I've given you most of the setup code. In fact, if you've already downloaded it, you might want to go re-download at least part of it, because somebody posted on Piazza today, there was one error in there in the C++ file. It's really easy to fix. You just add a binary search : : and that's it. But we've given you lots of the setup code, so this is not an assignment where you're going to have to write lots of your own stuff, except for the functions themselves. There are tricky parts in this one, right? Remove. You are going to have to write the assignment overload, and you're going to have to write a copy constructor. Well, kind of. I've given you most of that already, and the destructor. So be careful with that. Okay. It's tricky to write a destructor for a tree, because you have to navigate the whole tree. I've told you how to do that in the assignment. Okay. So I don't know if you remember, I mentioned that it's hard to print out a binary search tree. Like, it's not a trivial thing to do. Well, somebody wrote the function to do that, and they wrote it so it does little ASCII art tree. Well, I've included that. You don't have to write it. I've already included that into this assignment. So it will print out your trees. So if you go in and do some inserts, it will print out your binary search tree, right? The asterisk means that there's more than one 5 in this tree. OK? Well, I totally forgot to put a little count to say how many are in there, but it doesn't matter. You can write that in if you want to, but I'm not going to test against it. But this just means that there's at least one 5, or there's at least 2 5s. There's a 4, there's at least 2 8s, there's a 7, 9, 6, etc. OK, makes sense? Kind of cool. You can actually play around with this and see it, and the output will show you the tree. So you can tell whether or not you've inserted or removed properly. Kind of nice. OK? Really large trees aren't going to print well, because your screen's got to be like really wide, and it's not going to work. But otherwise, it should be good. OK? Questions on homework 4? No? All right. Here's the next thing. So this handout, does everybody at this point have a handout? If you don't, there's one up here. Ooh, you're the only one? You've got one now. Here you go. Come on up, grab this one. Oops. Oh, there you go. So what we're going to talk about today is this idea of writing the operations so that C++ will allow you to say something like object A equals object B of the same class. OK, that's the bottom line problem with this. And we have to walk through some of these things. We have to talk about like when you need to do this, what actually is going on, what the syntax is, and there's a lot to it. And it may take, we're actually a little earlier than we were in the other class, so it may take most of the class. But I'm going to give you a chance to practice this a little bit, and we're going to walk through it. And any questions you have, get them answered today. OK, so you got to pay attention to what we're doing, and you got to ask lots of questions about, like, I don't understand this, and we'll go through it piece by piece. OK? All right. We have already talked about the destructor, right? The destructor does what? What's the destructor do? It frees memory. It cleans things up, right? for certain objects, it has to go and go through all the nodes and free them up. If it's a dynamic array, it needs to do the bracket notation and do a delete on it, etc. And that's when the class is about to be gone. Okay? And that's when we knew that. We've talked a lot about destructors. We're not going to spend much time on this. There are two other functions that I've mentioned a bunch of times, but we've never gone into details on. And that's what we're going to be looking at today. There's this copy constructor. Okay. When you say something, C++ allows you to do a couple different things. Okay? C++ allows you to say the following. Let's pretend we had some class called A. Okay? And in A, there were some public functions and some public private functions or whatever. And then there's some private variables. Actually, it doesn't even matter that they're private, but there's some private variables. And one might be an int. Let's call it number. Right? And one might be a pointer. Let's call it a character pointer to something like name. Maybe you'd use a string, but in this case, we're just going to use a character pointer. OK? All right. Could we do the following? What if I say this? If I say A, let's say student 1. Can I do that? Is that a legitimate thing to do? No, why not? There's no, what do you mean there's no operator? This is a class name, and this is the variable we're creating. Right? So yeah, of course you can do that. Right? You can say the class name and then the student 1, and this creates a, let's do this. Instead of A, we'll call it S for student. And make it a little more clear, now we're talking about a bunch of students. And this is saying create a student called S. Everybody with me there? OK. What happens when we do that? OK? What happens when we do that? We have a student 1, right? And student 1 has some memory associated with it. OK? And that memory that's associated with student 1 there's two variables. One's called number. I'll just abbreviate num. And the other's called name. OK? Number is actually going to be some number that like 0 or 1 or 20 or whatever. And name, it's a pointer. So the name has some address associated with it. OK? Like 0x2a35. That's an address. It's just a place in memory. It's written in hexadecimal. Don't worry about those details. Just that's an address. Does that make sense so far? This now is student 1. So far, so good? Like we're OK with the fact that there's a pointer to some character. This is what student 1 looks like. A number and a name. And the name is some address. That's what a pointer does. So far, so good? OK. Let's create another student. S student 2. Stud2, we'll call it. Right? Isn't stud2 going to have the exact same thing? Num, name, right? Number is going to be, in this case, let's say it's 5. And the name is going to have 0x2943, whatever. It's an address. So far, so good? Everybody get that that's what we're doing. I really need you guys to understand that that's how it happens when you create these variables. Right? Student 1, student 2. OK. With a constructor, we're normally going to create that by using the new keyword, the actual name. Right? Like we do that when we have pointers, we need to use new to create the name. So what this means is once we do that, once we say new, blah, 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 there's going to be some name right here that this address points to. This is going to be at this address. OK? Does that make sense? Same thing for this one. This name is going to be at some address. Here's another name. OK. That's the setup for this whole thing. OK? Yeah, question?
Is the pointer associated with a specific address?
Absolutely. It's associated with a specific address.
And that never changes?
Unless you change it, it never changes. Right. Now, OK, there's some subtleties involved with that. The memory system can move things around as it needs to. But for your purposes, that number will never change. And you can rely on it through the time of your period, the time of your program. You can rely on it. OK? All right, that's the setup here. Now, the copy constructor is when we say the following. When we say student 2, actually, yeah, well, let's say this. Student 3, we're going to have student 3. We're going to have to create student 3, and we're going to say student 3 equals student 1. Is that allowed? Like, will the compiler complain about this, in other words? No, that's actually perfectly fine. What's happening here? Do we get another student? Yeah, we get another student here, student 3. Okay? And student 3 has a number and it has an address. Okay? And if we did nothing else, like if we didn't write any other code, if we just left the kind of everything in the way it was, what this says is copy everything from student 1 into student 3. Cool, huh? The compiler will do that for you. What it does is it says, OK, student 1 has a number of 0, so this is going to be 0. Student name is going to be 0x2a35, because that's the pointer to it. 0x23a5. That's what it does under the covers. Now, sorry, am I going on the board where you can't see?
No, you're fine.
OK, where does this point to? Points to this guy's name. OK? Points to this guy's name. That is probably not what you want it to do. Right? It's probably not what you want it to do. When you create a copy of something, do you want it to point to the same name? I mean, literally the same name. So in other words, if I went and changed the name here, that would change this. That would go and change student 3's name as well. Do we want that? Probably not. That's the idea that we have to worry about. The copy constructor says the following. No, 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 no. We aren't going to create that pointer. We are going to go create our own name area. We're going to copy the 0, because that's just a number, and we can do that. We're going to create our own name that's going to be some other address that points here, and then we're going to explicitly copy the details of the name into here. OK? Now, we're going to go through the details of this. You'll see it again in a second. That's one way to do it. That's the way to the copy constructor. That's one way to do a copy constructor. There's another syntax we'll get into in a minute too. But the operator overload for equals says, can I do this? Can I just say student 2 equals student 1? Can I do that? Yeah, nobody's going to tell them. The compiler will not complain about that. The compiler will say, sure, you want to do that. It does the exact same thing unless you explicitly write it. It says, hey, point my new thing to the old value there. OK, that's the idea. Now, questions on that before we go any farther? Yeah?
The way this is working, does that mean that if we don't have a pointer or any dynamically allocated memory in the class, do we not need a constructor?
Yes. If you don't have any dynamic memory in the class, you don't need to worry about it. You also don't need to worry about the destructor. So I mean, like if you get to a point where they're like, hey, no destructor necessary, you probably don't need to write these other two functions. If you do have to write a destructor, the odds are very good you'll have to write these other two functions. OK? All right. So here's what I want you to do. On the piece of paper you've got, OK? You have this, except it's better formatted. OK? And what I want you to do, first of all, let me explain a couple things. This is a constructor. It doesn't necessarily look like a constructor. But what it does is the following. See how I do this? This is an int cell class. See how I do int cell a2? That says, call this constructor, and the initial value is going to be equal to 2. If I do this, int cell c, notice I don't have the 2 in there. It says, oh, you're not giving me an initial value? Use the one I've already got. So if I do int cell c, it says, oh, you meant 0. So I'll use 0. OK? It's important, because last class we had lots of people like going, what is that all about? That's all that's doing. You can either give it an initial value, and if you don't give it an initial value, it gives you one for you. It gives you a 0. Bottom line there. OK? Second thing, this is exactly the same as saying int cell b equals a. It's just another way of writing it. Okay, it's another way of writing int cell b equals a. Okay? Now, here's what I want you to do. You can do this by yourself or with a partner. Go through this code, and what I want you to do is tell me what this is going to print out, these cout values. Okay? This is not a syntax thing. If there's some syntax error, I don't care. Point is, what's going to happen in this logically? Okay? Just go through it. I'll give you about 5 to 7 minutes. Walk through it with your neighbors or whatever, and I want you to see if you can figure out how to do it or what's going to happen. Okay? Hey guys, take a look at that. Try to figure out what it prints. Have a pen on you?
I don't know. I was like, I realized I didn't actually have to bring my computer, and I walked like 2 miles to get here, so I was like, oh my god, I don't have to bring anything, I'm free, and then I like didn't bring anything. So it's okay.
Well, you can figure it out.
No, yeah.
Let's figure it out. Let's figure it out. Okay. Tired?
Yeah, sorry.
Let's figure it out. What's it going to print out? Take a look at that. Try to figure out what it's going to print out. All right. You guys figure it out? Birthday girl, you got to figure it out? All right. I think we've given you, it sounds like people are pretty much done. Somebody throw out an answer. Rana, what do you think? 4, 2, 2. Okay, I'll buy that answer. Who has a different answer? What do you guys have? 4, 4, 4. Okay, that's another possibility. Who has another answer? I saw at least one other answer, unless you changed it. Nobody has another answer? Okay. 1742, 1, no. All right, nobody has any zeros or anything? Okay, all right, so no answer 3. Okay, let's take a quick poll. How many people think it's 422? Raise your hand. Okay, probably about half of you. So that means about, who was thinking it's 444? A little, maybe a few more than half, but about half. Okay, so it's about split even Steven. Okay, So let's walk through this and figure out what's happening. Okay? Because once we do that, we'll go, oh, I see. Okay? Let's figure out what's happening here. All right. We said this was the constructor. These are just two values that actually set the stored value. What's interesting about this? It's a pointer. Okay. You can consider this, if you want to be a one-element array. Right? An array to one integer. Right? But you do have to dynamically create that. Okay? In fact, this program has a memory leak. I don't know if anybody noticed. I do a new, but do I ever do a delete here? No. So memory leak. Bad Chris, right? But the point is that it has a new in there because this stored value is an address. Stored value is an address. It is not an integer. It is a pointer to an integer. Okay? All right. So that's what those are. That's what those functions are, and the value. Okay. What did we say this does? What do we say this does right here? I'll write it right here. Somebody tell me what that's doing right now. Yeah. It's okay. It sets stored value to 2 for what variable? A, and A is what class? An int cell. A is an int cell class. Okay? So let me do this right here. Here's what happens. The int cell class, it creates some memory for the int cell class for variable A. Okay? Inside variable A, there is a stored value. Right? Is that what it's called? Stored value? Yeah, stored value, which is an address. Right? That address is going to be like 0x239f, whatever. Okay. That's what that does right here. When this does this, what gets called up here? This part has to call something up here. Which one does it call? It calls this first line, right? That's the constructor, and it calls that line. So we do a little new in there, and that means we create a little bitty integer array right there. And what value do we put in it? 2. And that means that this address, let's pretend that we created this address at 0x29f, points right there. Everybody with me? Okay. That's what that does. What does this do? What did I say this does? It creates an int cell with the contents of A. Okay, so what's it going to be called? B. Creates B, and it says, oh, I know how to do this. Copy, copy. So now we've got a stored value equal to how much? Whatever that pointer is. So the stored value is 0x239f, which means that this points where? Right there. Okay? Does it ever call this function up here? As it turns out, it doesn't. It turns out it doesn't. It calls a copy constructor that the compiler created for you because you didn't bother. Right? You didn't bother creating it, so the compiler said, okay, you want to do this, I'd better create a copy constructor for you, and all it's going to do is copy those values. Compiler knows how to do that. Just copies that value. Okay. Everybody with me there? Yeah.
Question. What
Yeah.
if you tried to dereference A and get to the stored value of A when you pass it in as a parameter for B?
What if you tried to pass
But basically, if you did B parentheses A arrow stored value.
Oh, yeah, sure. This has to be an int cell. So notice A is an int cell.
Yeah.
So if this isn't an int cell, it'll go, I don't know what function you're trying to call.
Yeah.
There is no constructor that passes a value that's not an int cell. But you can pass the same class in there, and it says, oh, let's call a copy, so I'm going to make a copy of that. Okay? All right, so that's what that's doing. Okay. What's the next line do? Yeah, did you have a question?
Yeah.
Go ahead.
So you can create when you're creating A, when you're declaring it, you're creating it and putting to an int as a parameter rather than an int cell. How does it do that? And if it's
What int cell? Oh, yeah. Sorry. You're absolutely right. You're absolutely right. If you actually have a value, you're right. So you could have done, you're right. So you could have done that. You could have said, do the int cell value. You would have dereferenced it. You would have, the problem is, it is in the class. Its problem is it's private. So I'm not sure you'd actually be able to get it directly. even though this is the same class, I don't know that you wouldn't be able to say a dot stored value because, or arrow stored value because it's not, it's a private variable. So that's the problem with that. But yeah, you were right though. Okay, what's this line do, or this one do? Creates a new int cell, right? Called C with the stored value of what? Whatever this gives you, right? Whatever the value of that pointer, whatever that gives you, that's what it sets it to. So it creates it grabs another piece of memory of a length of one integer and says this is going to be 0, x, 3, 4, 7, and that is going to point here. And because we didn't give it any initial value, it's going to take this initial value. So what goes in this little box here? A 0. OK. Everybody good with the state of affairs so far? The next thing we do is we say C equals B. This is C. And that statement says copy everything from B into C. OK. What gets copied here? The pointer does, right? So this now is 0x239f, which means that this goes where now? Up to the 2. What did we just do to this one? We leaked it because we didn't delete that. It's sitting there going, hey guys, what about me? Right? That's leaked right now. So that's bad news right there. But that's not really what we're worried about right this second. Part of what we're worried about. OK, where does everybody point? Right here. Next line. A set value 4. What does that change? The 2 to a 4. And then what prints out? 4, 4, 4. OK? So you guys who picked 4, 4, 4 were correct in this one, right? And that's why. That is probably not what you meant to do, right? Or what we meant to do. It could have been. And there are probably cases where you'd want to do something like this. But generally, if you say C gets B, you want a copy of it that's called a deep copy. What you want is before, when C gets B, and this value was 2, right? What you want to do is you want to say, oh, don't change the pointer. Change the value. Like copy the value that's there into here. That's probably what you wanted to do. OK? All right. For now, though, that's what's happening. And that is what happened when, by the way, if we did have a destructor and everybody was pointing here, the first thing that got destroyed would go remove that memory and say, you're gone. And then the second one will come along and try to do what? Remove the memory, and you'd get this thing called a double free, which is what a lot of you guys saw in your output, right? You saw these double frees. Well, that's why. You had two things pointing to the same thing you're trying to free. Not good news. OK, David?
I mean, what was the incentive to not just basically allow the compiler to generate a deep copy?
Good question. Very good question. A better question is why allow the compiler to do anything for you? Because the question is, sometimes you might want a shallow copy. Sometimes you might want a deep copy. The big problem is, how does the compiler know that it's a node that's a binary tree structure? It can't figure that out, right? That's why it can't do a deep copy. It has no idea what your internal pointer structure is, right? Which is, by the way, part of the problem of languages like C++ that have pointers. There's not much you can do about a deep copy. Like, it can't figure it out. Right? It has no idea that you're setting things to null, and you're setting, and you've got lefts and rights, and it has no idea how to traverse your data structure. So that's why it can't do it on its own.
Right. I mean, I've done that a lot in other languages, and there's tools for different kind of, I don't know, they're not the cleanest things to do, but sometimes if you're just looking for like a quick and dirty
Yeah.
solution, you can get away with using some sort of way to make it
Well,
when it gets really complicated.
True, but you're probably talking about data structures that are already part of the language. because if the data structure is already part of the language, the person who created the language is going to know how to traverse it, right? But it's very, you can't create your own binary tree in Python or something and say, traverse it for me. The compiler's going to go, or the interpreter's going to go, I don't know what you're talking about, right? Because it's not going to, you have to build that in. That's what we're doing right here. We're building this in, okay? Whew. All right. Now, everybody's with me why this was 444. Everybody's hopefully with me about why that's probably not what we wanted to do, okay? And would have crashed had we tried that. Memory leaks and all sorts of stuff. Okay? All right. Output was 444. Okay. This is on your next page of code. Okay? This is a class called intCellFixed. In other words, I fixed it for us. Okay? The first thing we've got up here is the copy constructor. Okay? The copy constructor happens when we say this, b of a or b intCell b equals a. We do not yet have what we're trying to create. That is important. We do not yet have b when we call this. Do we already have a? Have we already created a? Yeah, we have not yet created b. We are in the process of creating b. This calls the copy constructor. Let me show you what the copy constructor actually does. Okay? Here's what it does. First of all, there's a lot of syntax in here that's annoying, but you have to just copy. By the way, I've never written a copy constructor where I haven't used an old example to copy from. Right? I don't want you to memorize how to do this. I want you to go find an example and adjust that example to be correct. Okay? Here's what it's got to have. First of all, this is a constructor. Why do we know it's a constructor? There is no return value. That means it's a constructor. Okay? intCellFixed is the name of the class, so this is a constructor. The const says, hey, I'm going to give you a copy of something, or I'm going to give you something that's an object. You're not allowed to change it. Don't go changing it, and it won't let you. intCellFixed is the name of the class again. Ampersand source is the thing that you are copying. In this case, what are we copying? A. We are copying A into B. Source is whatever A was. Then we create in this function we create a new integer, like we actually get a memory location for that integer. Then we copy the value from the old one, from A, into that new place, and we are good to go. Okay? Let's see if we can figure out what's going on with that. Down here, did anything change about this? Nothing changed. Like, this is the exact same line. Point is, what this is doing is the exact same. It calls the regular constructor, okay, and it creates A, and it puts a value of 2 in there, and we're good to go. This is the same right here. Okay? All right. When we do this, when we say intCell b of a, it calls the copy constructor, right? And that's when we get to do this. First things first. We create a new integer location in memory. We say, hey, guess what, guys? B gets its own location for an integer. That's what the first line here does. Then it says copy what's at, dereference the stored value in the source, which was A, and put it in the value that we just in the address that we just pointed to. So what gets copied into here now? 2. I didn't hear that fast enough from a lot of people, so let's pause for a second and make sure we get it. This is a pointer. When you say star to a pointer, you say, hey, I'm going to put something in your location. I'm not changing stored value. I'm changing what's at stored value, like what's at that address. And then this says the same thing. It says, give me what's at source stored value's address. So it says, hey, here's where stored value for A points. I'm going to take that value and put it into stored value of B. Question?
Why can't you reference the source and then have a period instead of an arrow?
Yeah, as it turns out, the period actually, I believe, has a higher precedence. So I think you can do it this way, where you could put a parenthesis around here, but it doesn't really matter. Really what you're saying is, you're saying dereference this, but it's part of source. So I think probably a parenthesis would make it more clear. That's all. OK? That's all that's doing. OK? All right. Everybody get where we are at that point? Yeah?
Do you also have to dereference source? Because source is a pointer.
Source is not a pointer. Source is actually a reference. You do not have to dereference references, as it turns out. You can just use them directly with the dot notation. Okay? It's not a pointer. Under the covers it is, but as far as we're concerned, we use it as if it's any other object. Okay? Yeah, question? Yeah. It's not going to be 0x293. It's going to be 0x47e, whatever, something different. Okay? And it's this here. This points here now. Okay? No, because source is not a pointer, actually. Source is a reference, not a pointer. Good idea, but it's not. Yeah, right idea, but it's not. It turns out you just use the dot in this case. OK. The next thing is when we do something like this. At this point is C created, when we get to this part right here. We're in the process of creating it, right? So this does everything the same as it did before. This says, create C, give it a value of some random place in memory, 0x222, and put the value 0 in there. That's what happens here. Okay? Here, we've now created C, and when we get to the next line, well, that's down here. When we get down to here, C equals B, that is when we said, hey, we have what we call overloaded the equals sign. In other words, equals doesn't mean what we thought it meant anymore. It means what we just created it to mean. And that's what this does. This is kind of an advanced thing, right? What it's saying is, first of all, return a reference to an int cell fixed. That's what it's saying. OK? And it's saying, change what equals means. Change what equals means. You can do that for any operator, as it turns out. Well, most of them. Any operator, you could change what times equals. You could change what minus equals. For the int cell fixed class, you can actually change what that means. That's kind of cool. This next line is interesting. Okay? Could I say the following? C equals C, semicolon. Is that going to cause an error?
In this code?
Not even in any code. Can I say int a equals 3, a equals a, like that? Yeah, why not? The compiler doesn't care at all about that, right? Some compilers might say, are you sure you wanted to do that? That seems a little silly, right? But no one will give you an error for that. That's perfectly legal code to say set a variable to equal to each other. Why would you want to do it? Who knows? But you can. The problem is, if we try to do that and it's an object that's going to be fussing around with memory, you're going to be in trouble, right? You want to check and make sure that you aren't trying to do this for yourself. That's what this does. And that's literally what this means. This means the object I am copying to. Is the object I'm copying to not equal to the source? If the object I'm copying to is not equal to the source, and this is a pointer, by the way, to the object. If the object I'm copying to is not equal to the source, I'm good to go. If it is, skip it. Okay? If it's not, then we do this. Stored value equals source stored value. All right? Which means, in this case, for C equals B, right? We have already got a copy of C. Right now it equals 0 in there. It points to a position, a thing that equals 0. That says copy the source's stored value, B's stored value, the actual what it's pointing to, into what we're pointing to. So what gets copied into this right here? Why is this so confusing? What am I not saying? It's 2. Here's where it comes from. B, it says copy what B is pointing to into what I am pointing to. Right? Boom. 2 gets copied right in there. Okay? Now we've done all that, what gets printed out? Sorry, I forgot to say the one thing. We set value A to 4. So we set value A to 4. What gets printed? 4, 2, 2. Okay? This is probably what you normally meant to happen. Okay? All right. Whew. Now, yeah, question.
So the purpose of the copy constructor and the assignment overload are the same, just because
Yes, the purpose is exactly the same. Now, first of all, you've got to worry about whether or not you're trying to copy into itself for this one. Second of all, I don't do this here because it turns out that because we're only dealing with one variable, I only have to copy one thing. What if I had the following? What if I had, instead of an int, instead of this being, instead of stored value being just one integer, what if it was a dynamic array? If it was a dynamic array where C, let's say that C looked like this, had a dynamic array that had 3 things in it, and B had a dynamic array that had 1, 2, 3, 4, 5, 6, 7 things in it. Can I directly copy all of B into C? What do you have to do? What did we do when we expanded? What did we have to do? We had to delete C. We had to create a new C that had the same amount of spaces as we're going to copy into. Do the copy in a for loop. And then set any other size and capacity and all that appropriately. Whew. Okay, you have to do that. This is why we need like for the queue, you guys were trying to do all of this stuff with a queue. Like you were trying to say q1 equals q2 or whatever, and it wasn't doing the copy. It was copying the pointers. Now you have 2 pointers pointing at the same thing, and you're in trouble. You need to actually do the full copy. David, question?
Yeah, so earlier it was asked in terms of whether we could just use the arrow operator instead. Would
Yeah.
that throw an error? I mean,
Yeah. Well,
the actual source, right?
you can't. Yeah, right. You can't use the arrow in that case. Yeah. You can't use the arrow in that case. Right. Yeah. OK. So here's what I want you to do. Well, first of all, this is going to be the output. Yay. OK. From homework 3, we had a queue function. OK. Take a look at what we're doing here. Q1, Q2, Q1 calls the copy constructor. Q3 equals Q1 also calls the copy constructor because we haven't yet created Q3. Q4 we create, then we say Q4 equals Q1 calls the assignment overload operator. All the destructors get called. If we don't build those, we crash our program, or we have double freeze, or we have ugliness. OK, lots of ugliness. Here's what I want you to do. You got 5 or 6 minutes to work this, by the way. We need a deep copy here. Right? We actually have to do the copy correctly. Here's what I want you to do. On the next page, you've got a blank page. And it is the copy constructor for your queue. Using the template that you already have from the previous example, which I will put on the board, you can write this, and you'll see what, and hopefully you'll write it. Now, first of all, think expand. You've got to do exactly the same as the expand. OK? Think I need to copy from the source to myself, which I can use just our regular old variables. I need to copy the capacity. I need to copy the size. I need to copy the front and the back. I don't need to do expand, but I need to copy the front and the back. You need to copy those. You need to actually do the copy of the queue array. All those things have to happen in the copy constructor. OK? So this is what I want you to write. You can work with the partner or whatever, but it takes 6 or 7 minutes to do it. OK? And I will go back to this one to show you what this one looks like. This one doesn't help too much because there's no memory management really in there, but do that. Warm in here, isn't it? No.
Those things don't change. Just copy them.
Just copy them.
One thing, and you want to get rid of it.
Yeah, so like, this, yeah, so the source plan. Store value of kids. Sorry, the new rate is what's
Yeah, Graham. If you wanted to, but you've got access to the internal variable, so you're probably not wise to do it. Turns out it's the same class. You have access to all the class variables. Yeah, you have, because it's the same class. That's really the reason there. Yeah, good question. Cecily, what's up?
You can do like this.
Yep.
So like you make a new array of students as opposed to a new store value.
Oh, that's a good question. You're not allowed to. You're right. You're right. Hey, Graham. Cecily brought up a really good point. You're actually not allowed to dequeue it because that would change the queue. So the const says you're not allowed to do that. Yeah. But you can access all the private variables of source.
Yeah, so you just take this at
Oh,
address.
but you can't.
You can access queue array directly.
Because you're being past source. Or you're past it. It's like start source dot student
I have put the answer up if you want to take a look at it while people are still finishing up. This is my answer. It's not necessarily what you have to have.
Yeah, source is whatever's in the array.
Yeah, anytime.
It's just, it's not, isn't it not like a copy?
It's not an exact copy. You're right. In this case, I made it not an exact copy. It's still a queue that has the same parameters, right? But it's not a deep copy. You could absolutely copy all the way up to capacity and make everything else the same. That's fine too. Okay. All right. So let me go through this. I did not expect you to get this exactly. Trust me. It took me a while to write this in general because you got to think about a lot of these things and do it a number of times before you'll do it right. First things first. We copied the size. This says what? Source.size, whatever the source's size was, is what we put in our size. Okay? Then I copied the capacity. Now, then I actually created a new array with the capacity of the source's capacity. Here, I was a little loose with a deep copy. Nitesh very correctly pointed out here. I actually copied it like I would copy a queue or do an expand of a queue, right? I said, we don't need to do that we don't need to copy all of the capacity. You certainly could. You could certainly say I equals 0, I is less than capacity, I plus plus, copy it all, and then set front equal to source front and back equal to source back, and you're good. Or back equal to source back, and you're good. I just said let's clean it up a little bit. Why not? It doesn't matter. You have to do fewer copies this way, but the other way you would make an exact copy in the other way. Okay? Questions on this? What we do? Yeah, Julia.
I still don't understand why you don't have to put star in front of source.
Ah, yeah, good question. Okay. That's what you'd think, but this is a really annoying C++ concept. This is not passing the point or the address of source. It's actually passing what we call a reference, which means you can use source as if it was a regular old class. I know the syntax is terrible. I never would have designed it this way, right? But whoever did decided they wanted to use that as the thing. It looks like it's pointing. Remember now, if you were to call this on your own, you would just say source. You would not say the ampersand when you're calling it. This is the definition of it. So we use the ampersand to say, I'm going to give you a reference. It is annoying, but the good news is you will always see it in exactly the same format. Okay, so you will always see it with this ampersand, and you will do the exact same idea with a dot. That's all there is to it. Okay? Yeah, question. Not a star where?
Like in the formulas when you're doing source.array.
Oh yeah. Well, remember, this really is saying, hey, I want to point. This is like kind of cheating a little and saying I want the value at QArray 0, right? You can use the brackets and you don't have to use the star. Remember, we can do that with arrays. That's all. We can just do it with arrays. Okay. Now, again, if you want to copy the whole capacity of the array, that's perfectly fine. You will make an exact copy. Perfectly fine. I just skipped, I just said, let's do it a little more efficiently. It's fine. Okay, now, guess what? I saw some people took a picture of the other one. That picture might come in really handy. This is going to be very, very similar. Here's the difference, though. Keep in mind, for the equals overload, you already have a Q array that you need to deal with so you don't have a memory leak. Otherwise, this is going to be identical. Try to write this one in 2 minutes. Or just talk it over. You don't have to write anything down. I thought we said we couldn't DQ.
This arrow size. What can you DQ from this? And this arrow size.
Oh, can you just go through and delete?
Because you're not. Oh, because it's constant.
You know what? You could DQ from this, but why not just, all you have to do is delete the array. I mean, you don't even have to like do any DQing, right?
I would say, did you do that? This and then you set your array. Wasn't that
Yeah, I asked. No, you should never call a constructor.
Well, no, because then you have like a bigger one. Then what if you have extra?
Yep, not allowed.
The copy constructor.
No, not allowed to call any constructors.
We have a new source here, right?
We do have well, yes, we have a new source. You have a different source, but it's a source. Yeah, so ampersand source just says, you mean this one right here? Yeah, that just says it is a reference to a variable, which means you can use it as if it's a variable. Now you can take the address of that variable, and that's what this does, but this is a different idea than this. This is a reference. This says take the address of that reference. That's what it means. So this is the answer to this one, guys. All we're doing is we're deleting the original Q array and everything else is identical. The only other differences are you need to check, and I gave this part to you, check if you're saying C equals C. Okay? Otherwise, yeah.
If we were to not delete the Q array and then just take out the line where we do the
Oh yeah, what would happen? What if they're if you check, if you wanted to, you could check if they're the same size. And that might save you some time, maybe, but most of the time they're not going to be the same size. Who knows, right? So it would just be a little more work. Yotam.
In line 1, if instead of writing, cost and Q source, if it wasn't a reference, it was just a source.
Yeah.
Then if you go down to line 3, would then the proper syntax be if this does not equal to ampersand source? So the
no, because it would give you, it wouldn't even work, because that would be passing a copy in there, and that wouldn't be work.
But how
Yeah.
can they that would say like if it's not equal to
You can't. You're not allowed. Yeah, you're not allowed. There's no way to do that. Sorry. I mean, you can't get the address of a copy. You can get the address of a copy. You can't get the address of the previous copy. I mean, you're not allowed. Not allowed. Okay, so that was a lot of stuff today. You can use this example and the other examples to do this for the homework assignments, right? You don't need to memorize this. I will never ask you to write a copy constructor or an operator overload on a test, right? I might ask you to recognize it or tell me what's happening, but I'll never make you write it. This is one of those things where it's just a lot of syntax, and you just, you got to sit down and write it while you're, drinking a soda or whatever your beverage of choice is, right? So you just want to, not take your time on it. That's that. All right, I'll see you guys Monday.